Hi, everybody. This is the next part of section 2.10, and this is a topic called elasticity of demand, very useful in business. And so if you have a demand function that gives Q in terms of P, usually every demand function we've seen so far wrote P as a function of Q, but we need one which has it the other way around, which is easy to get. And the elasticity of demand is E. Capital E, we write a capital E, and that's the absolute value of P over Q dQ dP. Now, why is absolute value? Because you see, demand is a decreasing function of price. Because the price goes up, the demand goes down, and vice versa. So since it's going to be negative, since its derivative is going to be negative, we want the absolute value on it, so E is always positive. Well, here's where E comes very valuable to us. If it turns out that E is less than 1, then the demand is called inelastic, and in that case, raising prices will increase the revenue. If E is greater than 1, then the demand is elastic, and in that case, raising the prices will decrease the revenue. Of course, if E equals 1, right on the button, then we say it's unitary, the demand is unitary, and that happens at critical points of the revenue function. Now, what is the significance of the number E? E is if you raise the price by 1, it turns out that if you raise the price by 1%, the demand will increase by E%. So when you figure out P over Q dQ dP, you get the percentage that the demand will increase when the price increases by 1%. Let's look at an example. So here we have an example. We have a company sells Q ribbon winders per year at P dollars per ribbon winder. The author of this textbook clearly has a thing for ribbon winders. Now, the demand function for the ribbon winders is given by this equation. P is equal to 300 minus 0.02 Q. So we want to find the elasticity of demand when the price is $70 and a piece, and we want to know, will an increase in price lead to an increase in revenue? And that's something we're going to use with the elasticity of demand is going to help give us that answer. So let's what do we need to do? Well, I would say that, let's say the first thing we need to do is to solve the demand equation so it gives Q in terms of P. And once I have that, I could easily take a derivative and get, dQ dP. So let's take a look at what it says here. P is equal to, so P, how did that happen? I don't want that. That's weird. Why did it jump up like that? That's weird. I don't know why that happened. P is equal to 300 minus 0.02 Q. And that means what I want to do here is I'm going to bring the 300 over to the other side. So P, negative 300 plus P is equal to negative 0.02 Q. Now I'm going to divide everything by negative 0.02 Q, and I'm going to get I get Q is equal to 15,000 minus 50p. And of course, I could take a derivative now. Q prime, I like that. I can fool it. Q prime is going to be equal to just negative 50. The last piece of the puzzle I need is I have to figure out what is what is Q when P is 70. Well, I just say that 15,000 minus 50 times times P, which is 70, because it's right, that's going to equal Q. And from there, I get let's see, 50 minus 30. So it's 15,000 minus 3,500, and that gives me that what's 15,000 minus 30? That's 11. That's yeah, 11,500. 11,500 equals Q. So we have here that Q is 11. Let me just get our ingredients here. So we're gonna put all this into the formula. So Q is that, P is 70. It says right here that P equals 70. And we already know that Q prime is negative 50. And this is all what I need to know. This is all I'm going to need to know for the formula. So I'm going to now plug. So we want that E. So E. Um, I don't need I don't need this anymore. E is going to be equal to P over Q. Excuse me. E is going to be equal to P over Q. E is going to be P over Q dq dp. So E is going to be, we're over here, P over Q, which is 70 over 1150, and then that's gonna be times the that's gonna be times dq dp, which is which is the same thing as q prime, which is negative 50. And that is going to be equal to, let's go ahead and put in a calculator here. 70, so 3, 5, now it's actually negative, but the absolute value is going to make it positive. So we're just going to make it positive. And now that's the answer. Is the demand elastic? Is it inelastic? Is it going to go up? Is it going to go down? Like what's the story here? So I'm sorry, so 0.3 is less than 1, which means the demand is inelastic. And if you increase the price, it's going to decrease the demand. How much of a decrease? It's going to be, since E is 0.3, so the decrease is going to be 0.3% decrease. So increasing the price by 1% would only cause a 0.3% drop in price, in demand, I'm sorry. And it, increasing the price, by the way, even though it's going to decrease the demand, it will lead to an increase in revenue. So the company may want to increase the price. And as we said before, just common sense, you increase the price a little bit, it'll increase you increase the price, even though it decreases the demand, even though less people are going to buy, you're still going to want to make more money because of the price increase. And you may want to say, hey, let's just keep on increasing the price forever. but that ain't going to work. And common sense tells us it ain't going to work because eventually it gets to the point where you're going to lose all your customers, and you won't make a penny. What's the term for that? You'll price yourself out of the market. That's how they say that. Okay, everybody, that's it for this video. I am going to make another video, part three, with another continuing on elasticity of demand and giving another example. So that'll be the next video. Meanwhile, this video has been a pleasure. It's been lovely and wonderful, and I'll see you guys next time. Bye.